So welcome everybody. I'm Phil Beavers, work from Telespazio. I'm chairing this session on EOEPCA, your exploitation platform out of the box. And as you can see, we have a long list of distinguished industry speakers with us today. So I'm going to say a few words, then hand over to our first speaker. Yes, of course, we're going to be talking about the project, the project for EO exploitation platforms, common architecture. But I hope it's going to be wider than that we can explore the challenges of big platforms, especially about interoperability. And we're going to hear about best practice, open standards, and open software. And we should have time for some questions. Anybody, please raise your hand in the chat or post questions in the chat. And if we don't deal with them as we go along, we should have time for that at the end. So here's our agenda. Without further ado, I'm going to hand over to Cristiano Lopez from ESA, who is, I hope you won't mind saying, one of the prime movers behind this initiative. And has served as the technical officer for ESA as well. So, Cristiano, over to you.
Can you leave the agenda just so people?
Okay.
So, welcome to this session on the exploitation platforms common architecture. So we'll present the work that we have sponsored or supported for several years now to create an open, interoperable, and standards-based architecture and related software implementation. Basically, this session complements two sessions that we had last Wednesday. And if you are watching this live, I hope that you also attended those sessions because they're complementary. You could get a good crossover, cross-fertilization. If you're watching the recording, I suggest that you go and watch those recordings also. We could even pause this one and restart after we have seen those. So let's start by focusing on the concept of exploitation platforms. The initiative started a few years back here at ESA when we realized that with the massive amount of data that the Sentinels and other Earth observation missions would be bringing, it would become very difficult to the users to continue with the old paradigm of downloading the data to their environment, to their analysis, create their outcomes, both result to papers and to other commercial users. And at the same time, the ICT world started to mature, and especially cloud technology started to mature, which gave form to the strategy to define a new paradigm shift, basically to bring the user to the data. So move the algorithm, the analysis closer to the data, preferably in commercial cloud environments with the same conditions to everyone. And we started different initiatives in this behalf, especially considering the European landscape, where it was clear, or it is clear, that no single solution, no single platform is desirable, given our multiple countries and our multiple conditions. So we evolved the concept into a network of EO platforms, let's say a loosely coupled federation of different platforms, different resources that are used in a collaborative manner to create the end result that the user wants. So a network where these users could come and move freely among different services, different platforms, consume the available resources as they needed to create their workflows, to create their own services based on other services according to their needs and their desires. The initiative, the exploitation platform initiative, was focused on different elements, and one of them was our work to create an architecture based on open interfaces so that these EO platforms could be as open as possible and to allow the user to move among them. So we decided to define the architecture based on interfaces that were standard and to a community process. To this, in this slide, we partnered with the Open Geospatial Consortium, with the OGC, and used their consensus process and used them as an open discussion forum to advance the know-how and the concepts used then in the architecture and used then by the different teams in this activity. So the common architecture, as you'll see, and you can see from the agenda there on the screen, is focused on different areas. We call these areas domain areas, domains of expertise. And in our work, we mainly focus on core elements of a platform. So identity and access management, what we see there as user management, processing and chaining, which could be seen as workflow execution, and resource management. So data algorithm services, the discovery and access of these. So we don't focus on what could be the business value of an organization. That we leave to the organization. So we don't touch HMIs or business cases and things like this. This is the organization. We try to supply the tools to work at a lower level for them to kickstart their activities or to validate the work they're doing, to align the interfaces so that they can intercommunicate with other platforms. So we'll start by hearing the overall presentation of the architecture, and then we'll do the different domain areas, and we'll hear also from 2 service providers that are using this to build their own commercial offers. Then, like Phil said, you can participate to a discussion. You can allow questions during the session. Please also allow questions in the chat. We try to reply in the chat or afterwards. And let's say if Marseille is already there, we'll have a keynote speaker now at the start, the CEO of Cloudflare and ERSC director. I hope he's available.
I'm here.
Thank you very much for joining. And let me just finish my introduction by thanking all of you for watching the session, online or offline, and for the presenters for taking their time to share their knowledge and experience with us, and to all the different partners that have participated in these different initiatives via the OGC, international partners, the ESA member states, and so many others that have collaborated with us. So thank you very much. I leave the floor to Mathieu. Thank you.
Hello. Hello, everybody. Okay, I feel a little bit nervous because online meetings are always a little bit complicated. One cannot see the audience, and I don't even know if you hear me, but I hope you do.
Yes, we can hear you, and I've made you a presenter. Can you share your screen?
I can share my screen, or you can. It depends, yeah. So.
Or would you like me to show your slides?
If you have them, maybe it's okay. I can. Yes, please. So if you can just share, and I will ask you to change slides. There is not so many of them.
Okay.
Okay. So let me start with this, even without slides. So I'm Maciej Krzyżanowski. I represent here ERSC, European Association of Remote Sensing Companies, and I am also a CEO of Cloudflare, a company that is running digital platforms. We are an operator of CreoDias, and we also provide technical means for other platforms like CodeD, German CodeD, or Cloud for VKO, other dias. So I can comment on digital platforms from both directions, from a direction of users of an organization, and I'm also inside of business platform, so we know how it works. Generally, digital platforms are already here. There are several. Yeah, so here we have slides. So please, next one.
Can you see that?
Yeah, I can see it, so I assume everybody can see. So
we can see that, but presentation mode would be preferable.
What can you see?
We see the slides in editing mode.
Yeah. So
presentation mode, we can see them a bit better.
That's strange. I can see it in presentation mode.
no, that happens something. Unfortunately, I'm not sure if. Okay, if you don't mind, let us maybe go with this mode. Okay, so digital platforms are here, and why we are talking about them, and why we as users community and also as providers of the service, we believe that they are or they can be important. There are several dimensions of importance of platforms. One thing is connected to the ease of use and readiness of resources. Basically, digital platforms are about a situation where some solutions, some data are immediately or nearly immediately available and can be easily accessed and easily processed. This gives just this streamlines the process of getting information out of data, because we know that historically preparation of environment of an environment to do something took sometimes 75% of the whole time needed to do something. So easy access to resources is one thing. The other thing is that around digital platforms, the user communities are building or can be built. So the people who are interested in some subjects can cluster around, and it's easier for them to exchange information. So it's closer to get together. Another thing is thing again going back to ease of use. This is the architecture of platforms. If they are layered, if they have open interfaces, open APIs, then chaining of solutions can become easy. And again, one loses much less time to get to some meaningful result. And then, since a platform is something that is used by many people, it's easier to get a resilient infrastructure, building something for many people, than doing it for a single project. And of course, if these digital platforms can be run on cloud provider solutions, and if they are run on European infrastructures, then this is additional advantage. This can be, let's say, sovereign or autonomous solution, not dependent on some outside technology. So in total, we believe that digital platforms can be an important asset in current world. And in a sense, there is a lot of competition going on around such solutions. And it would be great, and it is great, when Europe has its own approach to it, and it's not dependent on outside world. Please, next one. ERSC is and was interested in the development of platforms, and we wanted to share our views on such initiatives as a network of resources, ESA network of resources, because this is one of the ways to strengthen digital platforms in different ways. As I mentioned before, user communities are important. So one thing is just to get users using it and getting together. On the other hand, as I mentioned, digital platforms are also about getting to resources and being autonomous. And this is connected to set of subjects and set of areas that those digital platforms are concerned with. And again, network of resources can help to build and to strengthen such actions related with some specific subject and areas. Another thing is that when talking about digital economy, everybody looks for viable business models. These business models can be very different from the current one. In older ones, when one wanted to get some information, one bought a project from a provider. Currently, we are going more into the direction of information as a service, but it's not that easy to monetize this information because it's easy to open information in the internet on the digital platform. It's not that easy to get a revenue stream out of this. So network of resources can help defining new models of monetization of such services. And of course, the last but not the least important part is the anchor tenancy, because every such project needs investment. And on the other hand, it needs first customers. And the first anchor customer can be the one that makes everything viable and helps to get through the valley of death of a startup initiative or solution. Please go on. We are in a situation that after a few years of development, there are numerous platforms that are being developed by ESA or with support of ESA. And from the point of view of users, it would be useful sometimes if some mapping or catalog of those platforms was available, because sometimes we suspect that the usage of platforms could be bigger if people widely knew that they are there. Generally, we are happy that the platforms are based on horizontal tiers with open interfaces. For example, there is this restructuring of ground segment with instead of silos, vertical silos, there are horizontal tiers connected with open interfaces, everybody in the cloud. This is a direction the world goes, and we are happy that ESA is a promoter of such a way of doing things. And of course, since the platforms are there, it's reasonable to use them. On the other hand, the user engagement is not yet that big on platforms, but also if there is a consequent policy and something is doing in a longer term, it seems to work, and the use of best practices like pre-commercial procurement can make everything easier. But if we go to next slide, I will show that consequent policy gives results. This is the plot of the coming from ERSC's industry survey. This is 2021, so this means that it ends at 2020, and it shows sources of Copernicus data chosen by the industry players. And if you look at the green is 2018, and this let's say violet is 2020, you can see that in 2018, of course, Copernicus Open Hub was the most chosen source. But then the next one was Amazon Web Services. This is about autonomy, European autonomy and sovereignty. But in 2020, after 2 years of development, the ASIS are more used than Amazon Web Services, and Sentinel Hub is even more used. And you know, the ASIS and Sentinel Hub are just examples of digital platforms that are developed with the help or push from ESA and generally from European institutions. So this shows that if you have the policy and run this policy, this can generate visible results. I would say this is a very good result. Please go on. So commenting on this, digital platforms require long-term commitments and investments. Okay, the experiences from IT industry is just that break even for most of such projects are at least 4 or 5 years. And also, you know, to have additional private investment, one has to have enough of time horizon. One has to cross the valley of death. So for this, the long-term policy is necessary. On the other hand, if this anchor tenancy is provided, then digital platforms, if they are based on local competencies and local resources, they are just an important element of the extraction of information, of building user communities, and generally of building strategic autonomy of Europe. So I think this is an important subject in building new space economy. You know, it's not only about space, but generally also new space is going to be as a service, and it's going to build on digital solutions. Please go on. So if I were to summarize here, on one hand, digital platforms consolidate user communities and provide easy, okay, maybe not easy, but more efficient solutions to solve some problems. They are the platforms, they are strategic European asset in global competition. So this is another important factor. You know, also with building local competencies, workplaces, you know, everything important for the modern economy. And in the last point, they need time. As any enterprise, they need time to become, let's say, useful and self-sustainable at the end. So these are my comments on digital platforms. I hope that we'll see examples of this in further presentations, and generally that digital platforms are becoming an important asset that's going to be used by everybody. Thank you very much.
Thank you very much, Messier. Okay, let's move on. And I'm going to present a slide now. Can you see my screen?
Yeah.
Yes.
Screen, yeah.
So we've heard from Cristiano, we've heard from Messier. Now we're going to focus a little bit more on the EOEPCA project. And I want to start by just showing the team of people who are involved with this. We have, on the engineering side, we have Telespazio UK leading it as the system engineer. We have EOX and with EO Farm as experts in resource management. And TerraDue with as experts in processing and chaining, and Demos Space as experts in the user management. And these are the, as we'll see, the three domains of expertise that we're bringing together. And we also have on board two operators, Space Application Services and TerraDue, who will be taking the building blocks and that we develop and validating them in an operational context. We also have support from ERSC, the European Association of Remote Sensing Companies, from Massier and others, and of course the Open Geospatial Consortium, who we're working very closely with. And we heard from Ingo Simonis and Marie-Françoise Vaudot on Wednesday about some of that work, and also the UK's Science and Technology Funding Council, who've been providing consulting services. So this is these are all the people who've been involved with the project. I'm now going to hand over to Richard Conway, who is our lead architect and system engineer from Telespazio. Richard,
yeah, hopefully you can hear me. Just going to share my screen. Share. Okay. Are you getting a full screen presentation?
Yes.
Okay, perfect. Okay, so I'm Richard Conway from Telespazio. I'm the system architect for the common architecture. So we're slightly behind on time, so I'm going to try and go reasonably quickly. I'm going to basically introduce, provide a high-level overview of the common architecture. That should then lead into the following presentations, in which we tunnel in a little bit more into each of the domain areas. So Cristiano already introduced the concept of the exploitation platform that I guess we're already aware of. So the idea being, rather than download the data, the exploitation platform offers a cloud environment with hosted EO data and associated compute and tools, which should facilitate the analysis and processing. There are some benefits it's worth just identifying attached to this. So for the users, they benefit from the data proximity, scalability and performance of the cloud infrastructure, and they avoid the need themselves to have to maintain their own hardware. For the infrastructure providers, they gain potentially at least an increased cloud user base. And for the data providers, the data hosted in the cloud infrastructure reaches a wider audience. So these exploitation platforms offer a virtual work environment where expert users can access data, develop algorithms, conduct analysis, and share their value-adding products. The platform facilitates the sharing of data and applications, the idea being to create a collaborative environment. So it's previously mentioned that user communities can add real value to the experience of the users. So the TEPs are a prime example of these. So we now have this complementary ecosystem of platforms, data sources, and cloud services. And to fully exploit them, their potential, we anticipate the need to encourage interoperation amongst the platforms. The idea being that users of one platform can consume the services of another directly platform to platform, and that should be a seamless experience. I just wanted to try and sort of illustrate that concept sort of in action, if you like. So we can consider the workflow of a user. A user has a workflow and it draws on the services of multiple platforms. So first, the user logs in to their primary platform, so platform A in this example, and they have specific analysis that they want to perform. So they discover resources, some of which are in other platforms. Those resources can be data, applications, So the workflow is constructed by the user and submitted to the platform A, and it's executed, it's orchestrated by that platform. The platform itself interfaces on their behalf with the platforms B and C. Specific processing is performed at platform B, and the results are returned back to platform A to facilitate the next step in the workflow. At that next step, also there is some data that's required from platform C. So what we're able to do here is we're able to fuse some processing that's happened at platform B with some local data there, take the outputs, fuse that in some additional processing at from platform C, and then so the workflow completes with processing at platform A, which takes its inputs from the previous steps, and the final products are then made available to the user. This cross-platform flow is made within the context of the user's identity and access restrictions at each platform. So their actions must be accounted for, and their actions must be authorized in each of those platforms. So standardization through open interfaces seeks to reduce the friction between the platforms and these cross-platform workflows. So this is quite a simple flow, but we can imagine a much more complex nested workflows involving more platforms. What we need are interoperable interfaces that can make this possible. So this leads to our goal, so this desire for interoperability through standardization, which is to define and agree a reusable exploitation platform architecture by identifying a set of common building blocks that provide their services through open interfaces to encourage interoperation and federation within this network of resources. And as previously mentioned, so we have an architecture that we're defining here, but we're also creating a reference implementation of that architecture to validate it and to help us refine it. Very quickly, so we've sort of followed a process which starts with use cases of an exploitation platform. We have various inputs. We took a survey of other platforms. We also are leaning on best practice that's already out there in the industry, so CEOS, working closely with the innovation program and the standards of the OGC. So during the last 18 months, we've been developing our reference implementation. All our developments are open source and they're available on GitHub. And we're also working with operators whose role is to integrate the emerging reference implementation and to provide us some feedback. So very quickly on the use cases. So we have a document that documents a full set of use cases for an exploitation platform. We summarize some of them here from various actors, point of view of various actors. So consumers access the data processing and analysis services of the platform, including those of other expert users potentially. Data discovery, interactive analysis, execution of bulk and systematic processing, and the idea is that they receive a coherent experience when accessing multiple platforms using their singular identity. Experts will add value to the platform by developing processing applications, machine learning models, and engineering derived products from those, either to consume them themselves or even to publish them as inputs for other users. Importantly, they want their developed applications to be portable to other platforms. And the platform providers want to facilitate usage of their data and resources. So interoperability is important for them within the network of resources. And they want to be able to offer the users a seamless experience across those platforms. I'll skip this one because Phil's already introduced our partners, the domain areas, these three domain areas, and our partners in each of those contexts. So I just want to illustrate, this, what you see here on this slide, sort of represents where we are with our reference implementation in terms of the components that we have currently developed. And we have an instance of our current tip of our development deployed on CreoDIAS and also now on the Mundi DIAS. So we deploy to Kubernetes because that provides us a platform in infrastructure agnostic target. So we can establish Kubernetes as we have done in Mundi and CreoDIAS, and then our deployment can just go onto those platforms, and it gives us an abstraction of the underlying infrastructure. Each of the building blocks, so each of these subsystems we call a building block, and each of those is released as a container image. And we have supporting Helm charts for the Kubernetes deployment, and this is all available publicly in GitHub. So the ADES provides the engine for application deployment and execution, and it provides standard interfaces, API processes in particular, with the support to deploy and undeploy applications. We're supporting, and when we first started, we were very much supporting OpenStack as our sort of currency, let's say, for expressing references to data. But increasingly, Stack is emerging as a technology that's interesting to us and interesting in the community. So we're very much also standardizing on Stack also. So processing takes place in the ADES and can be published to the user workspace, which is the place where a user collects all of their resources within the platform. The application package describes the containerized processing application, and that's typically published through the resource catalog for discovery, and also from where it can be deployed to the ADES instance. And also we have a PDE, which we see as quite an important thing, which is a development environment built into the platform, which allows expert users to develop, test, and package their applications for deployment into the ADES. We offer data services, so data discovery through a resource catalog, which provides CSW, API records, Stack, OpenSearch interfaces, and also provides the input of references to the processing jobs, URLs into those catalog records. Data services provide standard-based access to platform and user-owned resources. So not only at a system level, but also from the user workspace, they're able to use the standard data access and catalog interfaces to access their own data. So the user workspace, it centralizes the user's management of their own resources. So for example, the outputs of their processing jobs or data they wish to upload to the platform as inputs to processing jobs. And it also offers as an abstraction at a system level through its API. The workspace integrates with the host platform. So for example, it provides an abstraction through which buckets, user provision buckets in the backend S3 can be provisioned. Finally, platforms, in order to have this seamless experience, we need to interoperate at a user level. So with federating user access for requests between platforms. So each building block is secured by means of an identity, our identity and access management framework. And at the core of that is OAuth, OpenID Connect, and user managed access for identity and authorization. So users authenticate through an external identity provider, and we currently support GitHub and ESA's Commercial Operator Identity Hub as external identity providers. So just wrapping up, so in summary, so really our aim, as I see it, is to provide a blueprint for an exploitation platform. Attempts to use open standards to facilitate interoperability and tackling some key problems along the way. We've embraced the applications to the data approach that has been trailblazed by the ODC Innovation Programme. So if you were looking earlier in the week, I think Ingo was presenting around this topic. So our reusable reference implementation is conformant to the recently published ODC best practice for Earth observation application package. So that's work that's gone through the innovation program and has resulted in a best practice. And so the end result is that application development is eased through the use of open standard interfaces that provide a consistent approach. And I guess there's two aspects to that. It allows the platforms to interoperate, and it also means that application developers have an application that they can have reasonable confidence is portable to other platforms. So there's sort of two layers to that interoperability. We'll probably wrap this up again at the end. Maybe Phil has a slide, but just very quickly, this is where you can find us. We're on GitHub, so search for EOEPCA and you should find us. And equally, we have a web portal, EOEPCA.org. So hopefully what I've done there is given enough of a high level of the whole system that then puts into context what we'll see in the following presentations, which will tunnel in a bit more to the domain areas. Okay, that's me done.
Thank you, Richard. Let's now move on to look at those three domains of expertise, starting with the resource management. This is about how you discover resources, that's data sets or applications. And so I'm going to hand over to Angelos and Fabian to talk about this.
Hello, everyone. Can you already see my screen and can hear me?
Yes.
Awesome. Okay. As already mentioned, I'll give you a brief overview over the EOEPCA resource management part. So this is the domain of both EOX and EOFarm. Just a quick overview. I'll give you an overview of the architecture. The resource catalog will be done by Angelos, and then I will head back to the data access service and ingestion. I'll also give you some insight into the user workspace and how it is set up. This is the team involved. And here we start already with the resource management architecture. So it is heavily based on Python. Most of the components are written in Python or are controlled by Python. As we have mentioned, already heard by Richard, so we are leaning heavily on Kubernetes and all its depending software solutions. So for example, we're using Helm charts to reliably install our applications, and everything is controlled and automated using Flux, which is especially helpful when we are developing our reference implementation on CreateOS. On the right-hand side, you see the overall architecture of the resource management system. You see it's comprised of many different system and building blocks and components. And they're all, as already mentioned, they're all managed by Helm charts installed via Flux. Some of those components are in a sense global, so they're installed only once in the whole system, and others are also installed once per user workspace. I will now give the chair to Angelos, who will introduce you to the resource catalog in that system.
Thank you, Fabian. So now I'm going to give some brief introduction and overview of the resource catalog. So the resource catalog component is there for the user to discover, search assets through the exploitation platform, but also through doing distributed searches along different platforms. We are implementing some basic standard from OGC and ISO as the standard for metadata, but also for the catalog service. And we are supporting, as already mentioned, harvesting, distributed, and federated search along the user, but also the system catalog. So the core of the resource catalog is the metadata representation. We are currently working with the model of ISO 19115 and 19139. This is the core metadata model, but we are we have an on-the-fly let's say transformation to other well-defined standards. The resource catalog is an OGC CSW reference implementation. We support CSW 2 and 3. This is a reference implementation of OGC for many years now. We are obviously supporting the core profile as well as the ISO application profile. And during this project, we have also implemented the OGC Open Search, geo and time, but also the EO profile in order to support more open search. This was a requirement from ESA to fully support the OGC Open Search profiles. Recently, though, since we are heavily involved in the OGC catalog standards working group, we have implemented as well the OGC API records, which is still in development. It's not final yet, but we are in sync with, we are synchronized with the development of the standard, and now we support OGC API records part 1, which is the core part, and this is already implemented in the resource catalog. And as well, we are developing the Stack API. We are already on the version 1 beta 2 of the Stack API, and we also support the Stack item. Next slide, please, Fabian. So these are the core catalog technologies behind the catalog. So we are using the PyCSW project, which is the OGC reference implementation server for CSW. We support multiple metadata formats like ISO, Dublin Core, etc. It works with flexible backends. Many database backends can be used with PyCSW. PyCSW is also an OSGeo official project. So it's open source. It's usable by everybody. We are also using OWSLib, which is like a Swiss Army knife Python client library for OGC web services. This can be used as a client. And we are also based on PyGeoMeta, which is a metadata composition library, Python library, and we are also we also have in our stack PyGeoEPCA, which is also a reference implementation server of the OGC API features. Next slide, please. So now I'm going to just show you a few screenshots of how the resource catalog looks like. On the left here, you see the landing page of PyCSW. This is the recent development branch we are doing for the project, and this is the landing page. It is based on OGC API records, so it's an HTML representation of the landing page of the catalog. Where you can see there are links for collections, the Swagger Open API document. There's always an HTML along with the JSON implementation there, and there's a list of conformance classes as well as the standards, the metadata standards that we support. So there's, for example, the CSW link there, and if somebody clicks that, you see the CSW endpoint on the right, and it can be used with any CSW client in order to discover data as well as application packages. Next slide, please. And while the landing page is in HTML, we obviously support the JSON output format. So here you see the same page on the left, but using the JSON output format, and also the Swagger document, which defines the capabilities of the catalog service on the right. Next slide, please. Okay, and this is where we go deeply in the catalog, and there's the collections endpoint where OGC API records defines the collection, and in this collection specifically, we have loaded some Sentinel-2 data. We have some demo data there to demonstrate how we can search through the catalog. And this is the HTML representation of the search outcome of the catalog with some paging in order to be able to browse the records. Next slide, please. And here, if we click on one of the records, we see the HTML also representation of the catalog record, as well as the JSON representation, which is used to discover data. So this is the OGC API part, but also we have a stack endpoint, and using this stack endpoint, you will see a bit similar representation, but also the JSON representation is conformant with the stack API. Next slide, please. So here, this is how somebody can use the resource catalog. So either through the UI that we already demonstrated, but by using a standard client of CSW or OGC API records or Stack. And in this case, we're using Jupyter Notebook to show you how somebody can define a query against the catalog, like a bounding box query, time query, and also some filters that can be added to the catalog. And using a very simple Python script in Jupyter, somebody can just get a bounding box of a record and be able to discover a record. But also, we can use other clients. For example, in the next slide, we can see the QGIS meta search client for the catalog, where somebody can search for a bounding box, or we can give the endpoint of the resource catalog, and then we can discover also data sets directly through a client in QGIS, where we can then use the links that are defined in the catalog record and add, next slide, please. We can see that we can add data directly to our QGIS project through the data access components like WMS, for example. So here we can see how we can simply search for a data set in QGIS through the catalog and add some layers, some data directly to our project. Next slide, please. So now back to you, Fabian.
Thank you. Good. We're short on time, so I will give you just a very quick overview of the data access service. So on the user-facing side, we have installed a view server, which forms the basis of the data access service. The data access service provides data access-oriented services, so like viewing or downloading the data for further processing. For example, it is capable of doing flexible WMS viewing interfaces. So on the lower part of the screen, you see the same scene, but only viewed as a true color, false color with infrared, or a dynamically calculated NDVI, which is then dynamically colored. This is always the same data register. There's no pre-processing involved. This is done dynamically from the source data. This is done using raster expressions, but we can also print the outlines of the image. We can do dynamic masking, and we can also, when we are dealing with larger scenes or bigger time steps, we can do property filtering, for example, using cloud coverage. Everything is then performance optimized using a WMTS cache or WMS cache to help with the viewing performance. We also support download interfaces, which support the WCS plus the EO application profile, and also the DSEO download for full products. Currently not really used, as we already have the system catalog. We also provide the OGC OpenSearch catalog interface. Ingestion into the system is done using a harvesting component, which uses the cloud infrastructure catalog to harvest the data from, which is then metadata enriched. So the whole product files are investigated and all metadata is extracted. This is then exported to a stack item, which is then passed to the data access system and to the resource catalog for final registration. The data access is comprised of the following components. So it has a PostgreSQL database, it has a renderer which is built upon EOX server. The cache is realized using the popular map cache application. We also have a registrar, which is again a renderer plus some Python logic. The harvest is also built using Python. For internal communication, we're using Redis queues. This allows us to handle large volumes of ingestion data. Also, there is a web client, which you can see on the right-hand side. So this is a browser-based client that is already available on the system, so that you can already use. So we have a direct view on the data that is ingested. So you don't need to install any third-party software to deal with the system. Also, we're using Elasticsearch, Fluentd, and Kibana. So this is the whole logging stack. This is especially useful for operators of the system, that they can track down bottlenecks or issues with the system. Also, a very vital component is the user workspace. So it is comprised of the object storage bucket. It has its own data access service, servicing the data on the object storage bucket. It also has a resource catalog. The resource catalog stores whatever the user has processed, but it is also a federated system to the system catalog. And the deployment scenarios is up to the operator. So on the reference platform, we have figured this out, what works best for us. There is a so-called workspace API, which controls the workspaces, where you can create and delete workspaces. And the buckets, the object storage buckets, are then dynamically created using the bucket operator that we created for the OpenStack on Creadius. So this is the fast RPA view of this user workspace API, where user workspaces can be managed. So in summary, we support open standards, we support free and open source software. So everything is realized with free and open source software. And we're using Python software that is battle tested, so to speak. As we have already seen, everything is available on GitHub. And yeah, I'd like to thank you for your attention, and I will hand over to Richard again, I think.
Thank you, Fabian and Angelos. Okay, so next we're going to look at the processing aspects. So we've seen how we can discover data and applications. So the next question is, how can we deploy those on a platform and manage that in a portable and scalable way? So I'm going to hand over to Fabrice at TerraDuo.
So good morning, this is Fabrice. I guess you can see my screen and hear my voice.
Yeah.
Okay, thank you. So thank you, Phil. I have a small slot to discuss the processing and chaining, how applications, Earth observation applications are deployed and executed, but also how applications are developed and how application developers describe their own applications so that they are an element, an asset that can be either executed locally during the development phase, executed in different execution contexts. For instance, I provide an example of running the application on a Kubernetes cluster detached, and the model how we manage to integrate that on the Earth observation platforms. So the goal is that you build the application once and you run it practically everywhere. So this is a challenging task. So I will try to provide you some context on how we got here. So we participated in several OGC testbeds, starting at a few years ago at testbed 13 and up to last year's to testbed 16. And the outcome of some of those threads within those testbeds was the definition of what we called an application package. And this is an asset that must describe the application, how it works, so that it becomes deployable on an application, on a platform, sorry. So the goal was then to find a mechanism to understand how platforms would consume that application package and make it available via WPS or today via the OGC API process specification. So, but during those testbeds and by design, the application package defined was targeting only the deployment and execution using the WPS or OGC API processes. So we found that there was an element missing. How can we make sure that the same application package can be easily developed on the platform or locally, easily deployable in other contexts, processing environments? Because, well, the exploitation platform is a mechanism to do it, but also interacting with these exploitation platforms, you have different execution scenarios, whether you're targeting end users that consume your application, or you're targeting your team that consume your asset and want to build something on top of that. So for us, it was important to identify new drivers, and the first driver that we identified when we visited the application package concept was to decouple the application developers from the exploitation platform and from the application consumers. So in the end, in practical terms, it was to focusing on application development by minimizing the platform particularities. So we didn't want really to create an application package that would say, well, this runs on this platform because it has this and this and that. So we had to create something that was more abstracted and covered the challenge of running it anywhere after writing it once. So we had to make sure that those applications were compatible with several execution scenarios. And then, of course, keeping an eye on the platforms, enable their exploitation to virtually support any type of package applications in different platforms. Those are the drivers. So if we look at the roles of the application package, it describes the data processing application, and as such, it has to provide the definition of the parameters, the software items, the executables, their dependencies, and metadata. So we must also ensure that the application is fully portable, supporting the execution automatic deployment in execution scenarios such machine to machine or different other scenarios, and also contain an information model to allow its deployment as an OGC API process compliant web service. In terms of the application development, so when you write an application package and you write your own application, the end goal is to create one or more container, and those containers will include the runtime environment, the software dependencies, and application binaries. So that we start by understanding that by building containers with the applications, we have decoupled the host running the applications from managing the dependencies and runtime environments. In the end, the host will only have to have a container engine such as Docker, Podman, or something like that to run that container. But then a container may represent a single step of the applications, and Earth observation applications often orchestrate different steps. And often we do that in a directed acyclic graph so that we can chain different steps of processing moments so that we end up with the product. And those steps, of course, can have a fan-out pattern, whether you are processing one input and generating one input for a stack of inputs, or a fan-in patterns where the step reads a list of products and generates one output. So by putting together containers and a way to describe the directed acyclic graph with the fan-in, fan-out patterns at step level, the obvious choice for us, and it was one of the conclusions of one of the previous test beds, was to use the Common Workflow Language, or a CWL. And the fact that the Common Workflow Language deals with an open standard for describing workflows and tools, making them portable and scalable across a variety of software and hardware environments. This looked at us like the good solution for describing the application package, and matched the challenge, the driver, that it had to be easily developable and deployable in different execution scenarios and contexts. Okay. In terms of data flow management, we heard Richard's introduction and Angelos and Fabian the description of how Stack is entering this exploitation platforms world. At the processing level, we use Stack as a way to describe the EO data manifest for the application inputs. And this way we have a standard way, a well-described way, and an easily consumable way by applications for accessing inputs. So what we also recommend is to use Stack as a data manifest for application outputs. So what is the application creating? Well, it could be a GeoTIFF, but a GeoTIFF alone will not carry metadata and the description. If it's a multi-band GeoTIFF, how do we recognize that what is each and single band doing in a result? And Stack brings that capacity. And so by using Stack as an input data manifest and an output data manifest, we can also chain easily different applications together and creating a meta service, okay? But the outcome, the practical outcome of defining Stack as input-output data manifest is that application developers have a clear method to consume EO data. So they do not rely on finds, globs, and grabs and things like that, and they stop looking at the content of folders in their applications. They have a direct access to the assets within a stack file, and they know that a red band will be a red band, or a sigma north band will be a sigma north band. And this is a great result. But also platforms have a normalized and common specification for the data flow management. So we know that the platforms deal with the stage in and stage out operations during the execution of an application package. So that must be decoupled from the application, and we must leave clear interfaces between the application and the platform. And Stack brought the solution for that, an elegant solution for that. Okay. And how does EOEPCA provide a way to develop the application package? Well, we have what we call the PDE. So the PDE stands for the Processor Development Environment. It is a service offered in the cloud, and it contains an integrated development environment based on Theia. It contains notebooks with JupyterLab. Well, if you want to do coding, exploratory tasks, or data, small data analysis, or interact with the results that are published on the platform already on your workspace, JupyterLab is there to support that. Well, it provides, of course, a container engine. This was a key driver for running and developing application packages, since we rely on applications that in the end require the build, pull, and push of containers. And it is linked to the workspace. So the connection with what Fabian and Angelos were describing, the connection with your own object storage bucket, your own catalog index, or other assets of the platform, the Sentinel-2 catalog, for instance. And then this environment is connected to continuous integration services. Often that can be exposed at platform level or at repository level. So GitHub Actions, GitLab CI, and things like that. So the PDE supports the development and the testing phases of the application package. And within that context, the application package is executed against reference data using a CWL reference runner, in this case, CWL tool. And this tool reads the application package, reads the CWL, and will spawn one or more container for each CWL step. So you see that you get the driver of having this fan in, fan out of the containers according to parameters, and you get the notion of the tasks can be processed in parallel if that's the case, things like that. CWL tool will take care of mounting the right volumes on the containers and making sure that inputs and intermediary results and outputs are read and written carefully and according to what the application package states in the CWL document. And so this is how EU applications interact with the development in EOEPCA, okay? So, but now that we have developed an application package, can we make sure that it is an object that we can run on different environments? And the example here is running the application package on a Kubernetes cluster. So we've mentioned that the application package is a way to make software portable and executable. And now let's see how it's done on the Kubernetes cluster. So for those not really familiar with Kubernetes, Kubernetes is an open source container orchestration system for automating computer application deployment, scaling, and management, providing a lot of services such as server discovery, load balancing, storage orchestration, things like that. In this case, each CWL step will no longer spawn a container, but will spawn one or more Kubernetes pods. In this way, we have the same approach that we had on while executing the application package with a CWL runner, such as CWL tool. But this time, while CWL tool would spawn containers, this in the end here we spawn Kubernetes pods. And if your Kubernetes cluster has a lot of nodes, you have the capacity to spawn a lot of pods. So in the end, you have quite a large scalability. And this time, inputs, intermediary results, and outputs are each read and written by the spawn pods according to the CWL workflow on persistent volumes in Kubernetes namespace, okay? So now that we know that the application package runs the same way on the PDE or your local computer, and it can run on Kubernetes environment. This seems that for us the obvious way was to put OGC API process on top of that. And so we have the Zoo project providing the OGC API processes level. It interacts with a CWL runner for Kubernetes, which is Calrissian. And we have Kubernetes providing the processing resources. So EOEPCA's implementation of the ADIS relies on those three components. And it allows deploying the application package. The deployed application package becomes an OGC API processing service that is exposed and ready to receive execution requests. And this is how we guarantee that we have a portable and application package that runs in different execution contexts and is deployed according to a standard, which is the OGC API process. So in EOEPCA, the way to consume an application package is either to go to a PDE and run that application package, or deploy it on the ADIS and then use the OGC API processes to submit execution requests. Okay, so as the conclusion, the first year and so of EOEPCA, so we managed to decouple the application developers from exploitation platform operators and from application consumers by creating an object that is not designed to only work on the platform, so that we can ease the development phases and make sure that what you see on your development environment is what we will get on the platform. So we cannot have differences at that level, obviously. So we provide cloud-native EO applications development environment for the developers, and we provide a multi-tenant, scalable, and transient processing resources using Zoo for the interface, Calrissian for the interactions with Kubernetes, and CWL for the application package. Okay. Thank you, and the application will be shared. So a few references behind, and Phil, back to you.
Hi, thank you. That was very interesting. And the next step, we're going to consider any processing or consumption of resources is going to cost money and has to be accounted for. And particularly if the data or application is commercial. So next, we're going to hear about how that user accounting and management can be applied in an exploitation platform. So we're going to hand over to Tiago at Electrodemos.
Hey, just share my screen. Okay, so hello, welcome to this presentation on user management, authentication, authorization, and accounting. My name is Tiago, and I'm currently the tech lead for the Demos team at the EOEPCA. So a brief overview of what we cover on the user management, which in many aspects is an engine running underneath. So there's an aim to provide an easy-to-use identity management system and also single sign-on facilities across federated systems. To also provide attribute-based access control via the usage of access policies, authorization, and authentication, and also user profiles for account and licensing management. There are some main concepts that we have to keep in mind. So there's the COI, or Commercial Operator Identity Hub, which is an identity provider sponsored by the European Space Agency under the Earth Observation Innovation Europe concept. The main objective of this service is to enable commercial companies to more easily access the Earth observation data and services. It is a deployed free service, and you can find further information at the indicated address. There's the AAA, Authentication, Authorization, and Accounting, which provides federated identity management functions with an authentication bridge for COI or EduGain accounts, including also authorization and accounting of usage over registered services like clients and applications, and also resources. Here you can see an example with the Next.js catalog, which is an example of a service that is backed up by the AAA. The AAA itself is a deployed paid instance, and the commercial contact point is David Perez from Demos at the indicated address. The EOEPCA implementation, it appears here as a technology development environment and architectural demonstration for the earlier concepts. Our current version of a user management is composed of 4 building blocks. The login service, which functions as the identity repository, management system, and authentication point. The user profile, which is a customizable web interface for user and licensing management. The policy enforcement point, or PEP, main entry point that can interface with different proxy solutions, where one is provided by default, and serves as protection and as resource management endpoint for resource servers. And the policy decision point, or PDP, functions as an authorization endpoint where the main decisions of the login service are made based on customizable access policies. This decision point can also be externally delegated onto another PDP. Here we can see the basic architecture of the user management solution. So the PEP, or policy enforcement, stands quote unquote in front of any protected resource we wish to have. In this context, a protected resource can be a resource server, something that contains actual resources that we wish to be protected, or even web interfaces and their endpoints and other services or elements. A user or a client issues a request for a resource, and authentication is triggered at the login service using OIDC. This part can be handled internally or delegated onto an external identity provider, such as COI. The authorization is triggered by internal access policies that make a verification call to the PDP policy decision. This in turn can make the decisions locally, or if indicated by the access policy itself, can actually delegate the decision onto an external decision point. In terms of use cases, for the login service, we have the resource registration, which is the main event for protecting a resource and ensure access control. We have the dynamic client registration, which uses OAuth 2.0 standards and is mainly used for the automation of platform deployment, and the propagation of a user identity by usage of JSON Web Tokens. And as we covered earlier, we can also delegate authentication onto an external identity provider or IDP. Now we'll quickly demonstrate this function. Here you can see an implementation of the user profile. As we click on login, we are redirected to the authentication landing page, and we can either log in with existing local credentials or select an external IDP. For this example, we are selecting GitHub, even though the procedure is the same for all IDPs. We are then redirected to the IDP's landing page, where we insert our credentials, and on successful authentication, we are redirected back to our user profile already logged in, where we can then proceed to use the interface. As a recap, so the user profile contains the interface for external IDPs, profile edits, account deletion, and other functions related to accounting and licensing. For the policy decision point, the use cases include actual authorization decisions via access policies, access policy CRUD, that is create, read, update, and delete operations, and the mentioned delegation capability. For the policy enforcement point, use cases include, on the default solution, we have the reverse proxy functions for resource server protection, and also traffic forwarding after initial authentication and access token validation by UMA Flow, UMA 2.0, resource path lookup, and also resource CRUD operations. For both the policy enforcement point and the policy decision point, an open API web page is available that contains the endpoints API for each system. And in terms of planned features for accounting and billing services, we have the pricing engine that will be used for rates and prices calculations, and it can also be called on by the PDP on the authorization phase. It also functions as a helper for the billing service. The billing service will receive and process billing events received from external components, establish associations between billing identities, and generate billing reports. And finally, the license manager will function as a link between the license constraints and the end users, performing verifications when paired with the PDP. That is all from my part, and I just realized I actually had my privacy shield down, sorry for that. I hope you found this informative, and thank you for your time.
Thank you, Tiago. Now I'm going to say a little bit about the resources that are available for everybody. This project. So let me just quickly share my screen. Can you see that?
Yeah, I've got it, Phil.
Okay. So it's already been said, we have a project website, and if you haven't been there already, do so after the meeting at EOEPCA.org. I'm not going to go through it all. I just want to highlight some of the content here. There's obviously information about the project and the team. We've got links to the documents and the software. There's a news page where we'll post the slides after the meeting if anybody wants to run through them again. And we also have a forum where we would really like to have some feedback and some questions. So I would encourage you, if you have any questions after this session, to post them on the forum. So about the documents, there are essentially three major documents that we've produced. Everything is free and open. The documents, there are links on the main website, but they're also posted on github.io. So we have a document about the use cases and about the master architectural design document, and also an interface control document. And these are in progress, so you can see the stable version, and you can also see the work in progress. The software, also free, is available on the GitHub repository. And we're currently at release 0.9, which is almost the minimum viable product. Release 1.0 is imminent in the next few weeks, we think. So there are a number of building blocks here that you can download, and there are links on the main website to the repository, or you can go straight to the repository. And also, it's been said, there are container images of the various building blocks which you can find on Docker Hub. So now we're going to hear from two of our partners who are acting as operators to take our software building blocks and to show what can be done with them. And I have to preface this to say, of course it's been difficult because the software is not yet a mature product. But first of all, we're going to hear from Bernard at Space Applications. Over to you, Bernard.
Yes, good morning. Can you hear me?
Yes.
Yes, I will share my screen. Okay. Do you see it now? Do you see my screen?
Yeah,
Yes.
I can see it.
Great. So good morning. So my name is Bernard Valentin. I'm the DevOps lead at Space Application Services, working on the EOEPCA operator, one of the two operator activities. Olivier Lamborel is the service manager, and Leslie Gale, who is also attending and can answer questions, is the community manager. So I have a few minutes to describe what we are doing in this activity and what we will continue to do all along next year as well. I will describe the main objectives, then explain how we set up the service infrastructure. Then I have a few slides showing what the service web portal looks like for the time being. Not yet available, but yes, we are working on it. Then about the community management, we will explain how applications or onboarding will happen. And finally, I will conclude with the next steps. So one of the main objectives is, of course, to build an EOEPCA-based service named, we will name it Crowd, to allow collaborative crowd-supported cloud-based development of EO applications. So Crowd being the fusion of crowd and cloud. The new service is developed from scratch. It will give access to the features implemented in the building blocks, but not only to those features, we will add also extensions. A particular focus, for example, will be on the creation of an advanced delivery mechanism, a flexible one that includes a customizable dashboard. So users will be able, and contributors will be able to customize how the data will be provided to the users. The development will evolve at the same speed as the development of the building blocks themselves. So you have heard that version 09 is available, and 1.0 is coming in a few weeks. So we are following the same release plan. Through this service, we want to lower barriers to get going and support using other services in the federated ecosystem of platforms. A second main objective is the evaluation of EOEPCA and evaluate how it can be used to create the next generation federated platforms. And finally, during the development, we will provide feedback to the building blocks developers about the usability and reusability of their building blocks in different environments. We have set up 3 environments. The first one is located at Space Application Services for development and testing. As soon as we move to staging or to production, then we have 2 environments in the CreoDS platform. We selected CreoDS mostly to increase the chances to smooth the deployment of the building blocks, as they have been and they are still actively developed and tested in CreoDS by the developers. The building blocks have dependencies, for example, Kubernetes, OpenStack. This has been mentioned already. We are also looking at how this can be addressed if we want to deploy the components in different environments. The web portal, it centralizes the access to all the platform features. The registration of users is free, as has been demonstrated just before. A user can authenticate with an external identity provider, for example, like GitHub. We distinguish different roles. The visitors, for example, who are not authenticated can discover the existing resources, resources being data products, applications, or training courses also, and they can access the publicly available ones. Consumers who are registered and given credits can discover, access, and use those available resources, possibly for a fee. And for that, we apply a pay-per-use model. Contributors is the highest level, I would say, role. These are experts who can provide to the platform new applications, new content, added values, products, and training material. And as I said before, the delivery of the data can be customized in flexible dashboards. On the right side, we see a preview of the homepage of the web portal. Here we have a few more screenshots of different pages that will be available in the portal. We can see the online documentation, the product catalog, so the tool to search for products available in the catalog. It will allow also to kind of bookmark the products in such a way that they don't have to be searched again. We also integrate a web client for the workspaces, the user workspaces that are backed by S3 buckets. So this web client allows users to upload their own data or download the data they've generated in the platform. And finally, we have a page for monitoring the execution of the applications. So the initial focus for the service will be the on onboarding applications supporting the analysis of the impact on health resulting from climate change and urbanization in coastal regions, these coastal regions being the most populated regions in the world. We will pre-populate the platform with relevant data sources, available applications and references. And when the service will become usable as part of the community management activities, we will present the platform and ask users to propose ideas and experts to develop and share their applications. There will be an open library of tools and applications available to facilitate the development of these applications. And as I said before, contributed applications and projects can be proposed for free or according to a pay-per-use model. Of course, we will reward the contributors with platform credits when their contributions are used. The next steps, where the building blocks version 1.0 will arrive very soon. It's a matter of weeks now, and as soon as it is done, we will integrate them and release the version 1.0 of the service itself. So we continue the implementation of the portal and the features not present in the building blocks. And when the service will be available online, we will contact domain experts and user communities. And for those users who want to give a try and contribute, we will support the implementation, the testing, and the publication of the contributions, of course. Voilà. So if you are free to contact us if you want to know more or if you like to be involved. We have the email addresses provided in this slide. Thank you.
Thank you, Bernard. Now over to our other operator, that is Tara Due.
Hello, can you hear me and can you see my screen?
Yes.
Okay, perfect. So you see a full screen presentation.
Yes.
All right. So I'm here to present you the Charter Mapper processing environment, which is an EOEPCA service based. Maybe differently from my previous colleague here, we are in a service that is an operational service that we put in place a few weeks ago. So what's this service first? This service is first designed from the Disaster Charter, which is a worldwide collaboration through which satellite data are made available for the benefit of disaster management by combining Earth observation assets from different space agencies. And in order to support operation with online services to access and visualize those EO data, we have been tasked by ESA to provide such a service via this Charter Mapper I will present you, and that is directly built and integrated within the Disaster Charter platform. So I repeat, this Charter Mapper is an operational service available since a few weeks now to project managers to provide disaster relief organization with satellite-based value-added products. So in relation with the general architecture of EOEPCA and what we have in this system, so we are, of course, based on a cloud platform, scalable cloud platform, Kubernetes. We have another access gateway with all the data stored. We have data service to access those data via what we call an asset repository. We have a catalog of service, which is both open search and stack. We have a processing framework, which is directly the ADES, which is developed in EOEPCA. We provide with processing services and application, as Fabrice explained to you before, using the application packages, CWL, and all the technologies associated. We have a complete service API, which includes, as I said already, OGC-based services such as OpenSearch, WPS, but also Stack now and other APIs that are used within and described within the EOEPCA architecture. We have, of course, a set of client libraries that we directly used to enable our portal, and several other services like WebID and command line client, such as virtual desktop using QGIS, Snap Toolbox, or Orfeo Toolbox. And of course, we have on top of that our users, which are the project managers of the disaster charters that are using all this stack. So one of the key concepts here is really processing and data, in which, as it was already presented by various colleagues before, we want processing and data interoperability. This is very important because we receive a lot of data with multi-mission data, with heterogeneous and various formats, and we need to process them in a, let's say, in a generic manner. So to that, we need first the data to be interoperable with consistent metadata definition, and that is provided with Stack and OpenSearch and the EOP metadata model. We package our application using the command, the CWL, and we deploy that on an ADES component for the workflow execution. All the data are stored in object storage, such as the resource management system presented by EOX. And we have a powerful and scalable processing cluster using containerization and orchestration of those containers. So all the platform business logic is implementing through what we call processing scenarios, that I will show you one right after, by combining those building blocks, the building blocks that are defined and designed in the EOEPCA architecture. This is a typical processing scenario we have. So we receive a notification from a space agency that says, okay, I have a new acquisition made for you, available for your system. So the first thing, after a few, let's say, verification about the availability of the data, one of the first key step is to harvest those metadata and to make this data available as a data set with generic metadata. And from this data set, we are then able to calibrate it and to make a more advanced data set, because a calibrated data set is what we call a process-ready data set. It means that it has in common characteristics, for instance, in optical data, characteristic about the band, saying, okay, it's a red band, it's a blue band, it's a near infrared band with wavelength characteristics, and all those informations are common and based on a common data model that is the same for all the data for all the missions. And from those calibrated data sets, we are then able to either propose a series of other scenarios that will produce what we call synthetic and systematic products, such as flood map, for instance, but also on-demand product made by the user itself using the catalog of data available. So this is another important concept in this platform is the process-ready data. So with this whole common architecture based on the fact that the data must be aligned and consistent, we have, using those technology we have discussed before, the way to query and easily access huge data sets. And on the fly, for instance, combining bands to make a specific maps out of the data we have. We ensure the metadata and the metadata relationship are maintained. And of course, we integrate that with tools, with high-level tools. And as I said, the process-ready data is the data made available with the tools, the documentation, and infrastructure to allow instant and easy access across the entire domain. So we are really, we base the work of the end user to the domain and not to the definition of the data itself. So will show you now, illustrate what we are talking about. So this platform, for instance, provide with optical calibration for multi-mission. So we have an end up to very high resolution and end user that has a true color RGB image that you can see on the map on the fly. We have the same for the SAR, taking in account the fact that can be different polarization and combining into a various type of model. Like for instance, here we have a full polarization overview because we have 4 polarization at our disposal. We have mechanism that allows to preview the data using sliders, for instance, to see pre and post event, to see the extent of a flooding, like in this example. We have the services that combines data itself. So it means that you pick up the bands of a data set to make another product, like NDVI, by combining the red and the near infrared band. It's of course this multi-mission, so it means that you can even go between the missions itself, but also applying very advanced mathematic expression over the bands to make a very specific product, like here a preliminary flood extent map from a Sentinel-1 data, no, in this case of a dark set. And of course, being able to overview different spectral indices from an optical data. We have also a service to make SAR change detection. And that's it for me. I wanted maybe just to show you what it gives live. I don't know, do you see my screen, still my screen in live right now?
Yeah.
Yes.
Okay. Okay. So if I have still a few minutes, I want to show you what it gives live. So we have here the workspace that the project manager sees on his screen with the call, what it's called here, a call it has been appointed to. And when it opens the application, it gets all the data set that have been pre-ingested by the system and calibrated. So it has access to a set of multi-mission data sets provided by the worldwide agencies, space agencies. And with those data sets, using the catalog, we are able to easily and quickly find the data we need, for instance here, and go quickly on the map to see what we have. For instance, in this case, we have a very high resolution Pleiad data, and from this information, with this data that I can zoom in, and as I speak right now, the data itself, it's directly fetched from the S3 object storage using a tiler. This tiler combines the data using the different assets or layer it finds in the data set. And the user is therefore able to pre-visualize. So I'm sorry, but my internet connection is really slow now. But using natural hurt, using the map and the acquisitions, we are able to overview, for instance, here an extent of a flooding extent, etc. We are able also to directly combine assets, playing with different assets and applying the value for overviewing the data. So, this is upcoming. I'm sorry, my internet connection is really slow. So maybe I'm going to show you another product such as this This is, for instance, a SAR change product that also allows to preview what could be a flooded area. So I'm gonna stop here. But if you are interested in any further demonstration of this service based on the EOEPCA architecture, please ask us at TerraDue. We will be very looking forward your feedback. Thank you.
Thank you, Emmanuel. That's great. So we are running a little bit short now, so we're going to go quickly to hear a word from our sponsor, that is Günther Landgraf at European Space Agency.
Okay, thank you, Phil. Thank you for everybody to have been paired with us so far. So let me summarize a bit what has been achieved here and what's the next steps. So as you heard, we are moving in a really highly technical environment where there is a fierce competition on the market. And what has it been achieved here is that the European technology is pushing the state of the art. We have seen in the OGC test beds where all of this has been brought together. The first test beds, 13, 14, were mainly ESA sponsored. But then in OGC, this was considered the most important area of innovation. And NASA, Natural Resources Canada have come in strongly. But we have seen even in the test beds that were mostly sponsored by NASA, from the NASA funds, it was always very many European companies selected to do the work as an acknowledgement that the expertise sits here. And this should be formalized now by the endorsement, the voting for the best practice on the application deployment, the OGC best practice, how OGC standards should be used to deploy applications on the clouds. We expect by November that this is voted and published, and we are already one step ahead. The open source that implements all of this, such that everybody can, out of the box, how the title of this presentation says, make its own data and cloud resources available via this best practice, will be ready right after this best practice is published. And it is not pushing the state of the art as a lab experiment. As you have seen, we already have 2 guinea pigs, and thank you for Space Application Services and TerraDue to try this out operationally and assess that this also works operationally. And my congratulations and compliments first to Cristiano Lopez, who has achieved this as technical lead, and we will really miss him. He is going to new adventures where his technical excellence is needed. But especially thanks also to the industrial team. I think you can really be proud of what you have achieved here at the International Forum. Now, this excellence is needed because otherwise in Europe, I think we can't compete. We have on the other hand, the Google and the Microsoft and the Amazon, and they are pushing their way of doing the things. And somehow, to balance this, Europe is Europe. To do Earth observation applications, you have to combine data from multiple sources. National agencies don't want to share their data in a central place. So the federation is what we have in Europe, what we have to address. And what we have developed here can be an answer. But what is really needed is now the cohesion, that we really now pull the same string and start to use that. And this, as European Space Agency, is what we want to support this next step. So we will offer entities who have data or who have processing resources to operate this open source stack on top of their offering. to make their assets available in an interoperable way to the community. Yeah. We will support this, of course, by the expert advice of the team that has developed it, but we will support it also by funding the effort that takes you to learn this and to deploy this on your infrastructure. It will need that also you fully embrace the state of the art. We have heard about Kubernetes, for example. So Kubernetes, the open source deployment, fully supports dynamic allocation and dynamic billing of cloud resources. And I can positively confirm that it's supported for the time being only by the T-Systems cloud. And thanks to you, Yuri, for setting the path here. I saw him in the attendees. But I'm convinced that the others will follow. And we hope also that this will be taken up by the national infrastructures. And I really dream that the thematic exploitation platforms, for example, can delegate processing of Prism data, which is a wonderful ASI mission, to ASI at Matera. And I'm happy to see Francesco Tattarani in the attendees. And on Monday, we will promote this also to the delegations. We have a common architecture working group meeting with the delegations. So very soon after the version 1.0 is ready for use, November, December, we will open this opportunity for everybody to come in to use in a supported way this open source software. And more than this, I'm convinced open source needs a community behind. Yeah? So we also want that you make this yours and you contribute to it. And there will be also a reward model for the contributions. And this will be published on ESA* as a best practice under Telespazio UK. You should look out for that. But we will take care that the interested stakeholders are all informed. And I see in the questions, so the interested stakeholders that we target is, of course, all of the Gaia-X proponents. And I think this is the way to engage here. We don't want and we cannot force anybody, but we will directly address these stakeholders, making them aware of the opportunity and see how they take that. So thank you, Phil, for this lot, for publicizing this, and back to you.
Thank you, Gunther. Okay, I just have a couple of slides to wrap up now. Okay, can you see that?
Yeah, coming through.
Okay, so just to recap, this is the agenda that we've followed. We need to be finished by 11, so I won't try and summarize all of these items. We did want to have some time for questions and discussions. There was a very interesting comments from Emmanuel Mondon in the chat about Gaia-X and some other initiatives there, which we will follow up. I probably haven't got time to open that discussion now, unfortunately. So I will just say, does anybody else have anything quickly that they would like to add or ask? Please raise your hand or post it in the chat, or from any of our panelists.
Phil, can I just ask on a logistical layer, what's in the chat? We won't lose that when the session ends, will we? That will be saved somehow, will it?
I will try and copy it, yeah.
Okay, yeah, because as you said, there's some interesting comments in there that we need to follow up.
Anybody else like to chip in? Okay, so last slide really, what's next? As we've heard, the version 1.0 really is, we think, only a matter of weeks away. So we can expect that in November. It's in final testing, just a few bugs to iron out. We will be working more closely with other ESA platform initiatives, including EuroDataCube and OpenEO, which we've been featured this week. Very interesting work that those initiatives are doing. We're going to keep developing the software, and there will be incremental releases 1.1, 1.2, so on. It's very exciting to see what TerraDue have done, and we look forward to the operational platforms being demonstrated by Space Applications and TerraDue, and we'll post some news about those as soon as they're available for public. You can participate, as we've heard, in a number of ways. Please review the documents. There's a lot of them, but we'd welcome any feedback from that. You can try the software, and if you have any questions or about that, we're happy to receive them by email, or better still via the forum, which is on our main website. In fact, I did start a thread about Gaia-X, so if anybody wants to join that discussion, that would be interesting. You can tweet us, hashtag us, and there is the email address for the system team. So, just like to say thank you to all the speakers. Very interesting selection of views and technical details. And we look forward to wider participation in future. Thank you.
Thanks, everybody.
Thank you, everyone.
Thank you, everybody. Thank you, Phil, for moderating.
Thank you.
Thank you.
Thank you, everyone.
Thanks.